Now let's consider a particular problem. Given that dy dx, or some function's derivative, is equal to x over y, sketch the slope field, and then sketch the particular solution passing through the point 1, 0. So, in terms of organization, we might consider making a quick table of x and y values. And when x is 0 and y is 0, then this would mean that x divided by y would be undefined. And this would be true for all values of y. Let's get a few more and then we'll start doing some more work. And so if we filled in our table with particular x values and particular y values, and we see that at the point 1, 2, the slope of our line is 1/2, so it's going up, but not very steeply. Something like that. And at 1, 1, the slope is 1, so it's a little bit steeper there. And at 1, 0, it's not defined. At 1, -1, the slope is -1. And at 1, -2, the slope is -1/2. We'll do some more points for 2. And when the x values are 2, for the corresponding y values, at 2, 2, the slope is 1. And at 2, 1, the slope is 2, steeper there. At 2, 0, it's undefined. At 2, -1, the slope is -2. And at 2, -2, the slope is -1. I'm just approximating what this is going to look like. I'll do the same for -1 and -2. So when we do this for the x values of -1 and -2, we have these slopes. Now we have a question passing through the point 1, 0. Well, this question is kind of stupid, and I should have noticed this, that at 1, 0, this is undefined, so there would be no solution based on that point. So let's change it. Change the question to the point 1, 2. And this is important because we do know that at 1, 2, the slope of our function is 1/2. So I'll do that point right there. And to sketch in the particular solution curve, then, I know that I need to be tangent right here. I know it's trending up, and I can see that as I go to the right, the curve is going to be getting steeper. So I expect it to be like something like that, just getting steeper and steeper. And I can see that when I go to the left, it's flattening out, and it's getting steeper. Some way, that's what it's going to look like in this region. That would be the best I could have. And one important principle is it needs to be tangent at the point in question, and it should never, ever cross at any other point. If I were to sketch something in, let's say through the point -1, -2, I want to be tangent right here for my curve. And I can see that it's trending back down. I, as a principle, never want to run into any of these other tangent lines. So my sketch might look something like that. Oops. The two possible solution curves for this particular thing. What's really nice about this is that if you were to integrate dy dx equals x over y, you would find that this would be equal to y equals the square root of x squared plus 3. This graph is kind of like either one of these depending on the particular solution curve. Right? The value for c determines which of these it would be.